In this video, we'll be looking at forces, specifically gravity, and how it affects an object. We will look at an object falling in a vacuum with no air resistance, and then how it affects an object falling through air. A force is defined as any influence that tends to accelerate a mass, or an object for our discussion, a push or a pull. Gravity is a force that pulls down on us toward the Earth. Gravity will cause an object to consistently accelerate toward Earth at a constant acceleration rate of 9.8 meters per second every second, or 32.2 feet per second every second. The ball's velocity will increase the longer it falls, as will the distance traveled. If an object is falling toward Earth in a vacuum where there is no air resistance, it will accelerate faster and faster until it runs into something. Now, air resistance is defined as friction or drag that acts on the object moving through the air. If the same object in a vacuum was falling through air, its velocity would be slower because of the air molecules that have to be moved out of the way. As the object's velocity increases, the rate of acceleration decreases. Terminal velocity is reached when the friction of the air equals the weight of the object. Now let's take a look at different objects that have different masses and shapes in a vacuum. Notice that the brick, the bowling ball, the dumbbell, and even the feather will fall at the same acceleration, velocity, and the distance traveled are the same. However, when these objects fall in Earth's atmosphere, they will encounter air resistance. Their shape and weight will determine their terminal velocity, the point at which the air resistance moving around the object equals the object's weight.